Welcome, everyone. This is the great keynote for cyber science. My name is Martin Joten. I will be chairing this session. And to quote Gary McGraw, I'm super pleased to be able to introduce Steve Lipner today. Steve Lipner is known by many as the point man of Microsoft Security Development Lifecycle, or SDL, and is also co-author with Michael Howard of the book with the same name. He retired from Microsoft in 2015 as partner director of software security and is now continuing the good fight for software security as executive director of SAFECode. And without further ado, please go ahead, Steve.
Thank you, Martin. Give me a thumbs up, assuming you can hear me. Okay, great. Thank you. So what I would like to do is figure out. There you go. Okay, I think I now have control of the slides. And so what I thought I would do this morning, as it is in Seattle, or this afternoon, as it is where I guess most of the attendees are, is to just walk through some of the lessons we've learned about secure software development over the 15 or so years since the security development lifecycle was created, and over the 20 or so years, 25 or so years since I or Microsoft first got involved in this adventure. I, of course, have been doing cybersecurity for about 50 years, but that's probably another story. What I wanted to do this morning was to start with some of the history that got us into creating the SDL, and then go from there to the set of things that happened that led from Microsoft deciding that it was interested in doing security right or better to actually the creation of the SDL. And then after that, I'll drill in a little to the things that made it work, and conclude with some lessons learned and some thoughts for the future. If there are people on the call or in the session who are responsible for secure development at their organizations, they're responsible for getting their organizations to adopt secure development, I hope there'll be some lessons that you can take away. And similarly, if there are some researchers, I think that along the way, I'll introduce a few considerations that might be of interest to you as you look for new topics. So let's get started. Microsoft, as you probably know, was created in 1975, and the big, well, they had several big breaks: the IBM PC, the creation of Windows, and in particular Windows 3 and 3.1. But the company's real commitment to something that would drive them in the direction of security came in the late 80s and early 90s with the creation of Windows NT. Windows NT, as you probably know, was based on a system that a team at Digital Equipment had started working on. It was aimed at achieving the U.S. government security certification, what was called C2 at the time. Sort of think of it as common criteria if you're more familiar with that. And it was intended to be sort of state-of-the-art secure for whatever that meant in the late 80s and early 90s. And Microsoft did all the things that you were expected to do, in particular, introducing a lot of security features into Windows NT as they built it. And so that was sort of the background or the environment in the early 90s as things really changed with the way folks thought about security. And one of the changes, I don't know how many of you have seen this issue of FRAC, was the introduction by a guy who went by the name of Aleph Null of of exploiting the technology for exploiting buffer overruns, and what he referred to as smashing the stack for fun and profit. Buffer overrun vulnerabilities weren't new. We had them in the creation of the Anderson report in the early 70s. The internet worm of the late 80s exploited one, but for some reason, maybe because of the internet and the wide availability of PCs that claim some level of security, the FRAC article is really viewed as sort of the milestone that made people aware of that sort of problem. Closer to home, Microsoft, with the introduction of Internet Explorer in the 90s, also introduced something called the ActiveX control, which was the way to download a native executable, signed native executable from a website, and then have it run on your machine. And there were supposed to be a number of safeguards that kept you from downloading hostile executables, but a group of folks, I don't remember the attribution of this one, decided just to show Microsoft that maybe they weren't as smart as I thought they were, created something called Internet Exploder, which was an ActiveX control that would download and then crash I think it would crash your browser or crash your machine, and teach Microsoft that maybe they didn't know quite as much about security as they thought they did. With those things, with the Internet Exploder, with other vulnerabilities discovered in the browser, with people using buffer overrun attacks and other things to demonstrate vulnerabilities in NT, Microsoft decided that they really had to start to think about security and think about it in a way other than building security features into NT in the browser. And with that in mind, they created what was called the Security Response Team, which was an organization that was chartered to accept vulnerability reports from the outside, from people like the folks who discovered created Internet Exploder or discovered buffer overruns. They would report them to the Security Response Team. Security Response Team would work with the product group to get the vulnerability fixed, and out would go a security patch. That was the process that eventually evolved to be what you think of as Patch Tuesday. Microsoft also, beyond just creating a response team, actually did start to think about what could they do to improve the security of the software they were delivering. And with that in mind, they launched a security task force from within engineering with the aim of thinking about what the problem was and thinking about ways to address it. One of the outputs of that security task force was a paper called "The Threats to Our Products," which actually was the origin of a process called threat modeling, about which more later. Another output of the security task force is the creation of the Secure Windows Initiative, which is a team in the Windows security group composed of 3 program managers who were supposed to review the design and implementation of Windows and file bugs to get all the security problems fixed. Now, at the time that these 3 program managers were reviewing Windows, there were something like 8,500 people in the Windows division and 40 million lines of code. So you can do the math on your own about that. But at least there was the attempt. In the late 90s, I actually joined Microsoft in late 99, and I joined it to run the security response team. Over the next few months, we relaunched the security response team as what we called the Security Response Center. That's what it's still called. We added a number of people. We stepped up our resources, did a number of things to try to do a better job dealing with the folks who found vulnerabilities in our products. The Secure Windows Initiative team realized that trying to find all the bugs and get them fixed was not something that 3 program managers could do, and they switched their mode of operation to training on secure development and what they called bug bashes, which would involved working with a product team to identify, to review its code. The product team would get trained, the product team would review its code, and the product team would attempt to identify and fix security vulnerabilities. Okay, I have now, there you go. Okay, yeah, all right, I'm trying to teach myself the slide advance. And so, so things were sort of on a little better track, but it wasn't by any means a walk in the park. There was a major intrusion into the Microsoft internal network in late 2000, which didn't do a lot of damage, either in terms of no modification of sources or anything, but it certainly got publicity and not good publicity. In 2000, that's not good. In 2001, we had the code Red Worm, which infected the IIS browser that was part of Windows NT 4 and Windows 2000, and caused a lot of disruption to people who were using Windows servers on the internet. A lot of publicity, all of it bad. That was followed in 2001 by the Nimda worm, which also mostly affected IIS servers, but it also had vectors on the client, including email and the browser as well. So another multi-billion-dollar disruption to Microsoft's customers. And that was followed by the discovery of what was called the UPnP vulnerability in Windows XP, which was thought to be a way of gaining control of an XP system. Whether it was something we never were quite sure of, but it certainly had the property that you could send traffic and use it as a DDoS engine. There's actually a similar vulnerability in play last week that I was reading about. But the UPnP vulnerability caused embarrassment, a lot of headlines. This is the Seattle local paper from the era, and also again got a batch of customer dissatisfaction with Microsoft and its software. Along the way, somewhere, Gartner Group published an advisory to customers that basically said, gee, if you're using IIS web servers, the security there isn't really good. Maybe you ought to think about using something else because Microsoft just doesn't have its act together. So that was pretty embarrassing. And again, people were aware of that, partly because of the press, partly because customers were yelling at us. There was a story that no Microsoft executive could have any conversation with any customer in 2001, early 2002, about anything but our bad security. And so in response, the late Howard Schmidt, who had subsequently worked in the White House under both the George W. Bush and Obama administrations, and Craig Mundy, who was one of our chief technology officers, started to push for a corporate commitment and a change to the way we would do things. And that push started after the CorpNet intrusion in late 2000, and it was the usual thing that a big company does: meetings, emails, briefings, demonstrations, meetings with Bill Gates, meeting with executive vice presidents. What should we do? What's the problem? How do we address it? In parallel with that, Michael Howard and David LeBlanc, two engineers in Microsoft, were writing a book called Writing Secure Code that basically put down on paper everything they had learned about secure development and the ways to make software resistant to attack. That book was published in early 2002, but had been under development probably since 2000, and turned out to be both a resource and a visible statement that Microsoft had something that it was capable of doing. And as a result of the Howard and Craig initiative, Bill issued in early 2002 an email to all employees that said basically, security is important. We haven't been doing a good job of it. We need to put security first, and we need to do it better. And that was a big deal. Those of you who remember the history of computing in the 90s remember Bill's email about turning Microsoft to focus on the internet as a change of direction that had a major impact on the company and the industry. And people viewed the Trustworthy Computing commitment as a similar milestone and a similar change for the way the company addressed things, but not all of them. Some people were skeptical. My friend John Pescatore from Gartner issued a note that said essentially Microsoft has this terrible product security problem, and in response what they've done is issued a press release. So you know, that was a bit of a put up or shut up. And fortunately, we had a way to put up. We in late 2001, the small team that I ran, which was by then both the Secure Windows Initiative program managers and the Security Response Center, had a management offsite, and we were talking about, you know, problems and approaches to actually making security better for Microsoft products. And Michael Howard, who is part of the Secure Windows Initiative team, had been working with the Common Language Runtime, the .NET Framework team, as they were doing their version 1 release. And they had gotten to a point where they had these security bugs kept getting discovered, and they were trying to find them. They were doing a pretty diligent job. And so eventually the general manager there said, okay, let's just stop development, take everybody on the team, put them all to doing security reviews, and we'll do that until we don't find any more security bugs. And that approach seemed to me like a potential way for us to change the landscape for Windows in a big way. So I went to my boss and I said, hey, what we ought to do with the Windows version that's under development at the moment, it was Server 2003, is stop development, train everybody, tell them to do security reviews and fix all the security bugs. And his response was, we can't tell them enough, they won't be committed enough, they'll just roll their eyes and go back to writing functional code, and we won't accomplish anything. But he asked me some questions, and he said, okay, how would you do this? How would you do that? What would we do? And he told me to come back. And as I kept coming back to meetings, there were more and more questions, but each meeting was with a higher level of management, for my boss and then his vice president, and then another meeting with his vice president and the senior vice president who ran the Windows Core group. And eventually we got to a meeting with a group vice president, and his question was, okay, when do you want me to preempt the conference center so we can start the training and actually do this? And at that point, I don't think anybody ever sent me an email that said this is approved, but at some point it was evident that we were actually gonna do it. And so that led to what we called the Windows security push. And that was something that did get people's attention. And it was hard to be cynical about, because we stopped development. We took 8,500 developers and put them in a room, 900 at a time, 10 times over the course of a week, for 4 hours of security training on how to do secure development, how to avoid security bugs, how to recognize security bugs, how to test, other things that basically were a curriculum, the 4-hour curriculum based on Michael and David's book. And at that point, you know, the question of how do you get people to take it seriously, there were a lot of things. The Bill Gates email was one. Gates didn't send those emails lightly, and everybody in the company knew it. The reputational impact, things like the Seattle PI front page was another. People were embarrassed to work at Microsoft. And the third that I've always thought was important, you had this half-day session, and you know about corporate training. If you worked in a company, you know, you have this mandatory training. It's very important. The vice president shows up, introduces the training subject, tells you why it's very important, and then leaves while you sit through the training. In the case of the Windows security training, we had each half-day session introduced by a Windows vice president who sat through the training for the full 4 hours, because they understood both that this was important for their, you know, what they were asking their people to do, and it was also an important message to the developers. So the developers actually took it seriously. We wound up spending 2 months shut down. These are some of the things that we did. We inventoried every component in Windows and assigned it to a group to review and sign off the security review. We did manual security reviews. I'm not going to read everything. We had a static analysis tool called Prefix that was centralized, pretty new, but it would find security vulnerabilities, including buffer overruns. So we ran it on a batch basis every week or two, and then sent the bugs off to the product team that owned the component. We started down the path of modifying defaults. If not everybody needs this, turn it off. And then if there's a vulnerability, most customers won't be affected. In the security response era, there was this culture that, you know, can it be exploited? If it can't be exploited, maybe we don't have to bother to fix it. We changed the answer there. If you found something and it looked like a vulnerability, the rule was just fix it. It's cheaper to fix the potential vulnerability than it is to figure out whether somebody can actually exploit it. And if you try to figure out that somebody can actually exploit it, you'll probably get it wrong. The way we operated during that 2 months, the Secure Windows Initiative team and some other folks who were security expert across the company served as advisors and reviewers, but the Windows developers basically did the things on that list below where it says 2 month security push, and they drove the process. And I've always said, you know, it's actually a 2 month security push, but probably delayed the product by 6 months or more because of the need to go back and retest, re-review, fix some of the bugs, redocument the other things that we changed during that period. And that got us Windows Server 2003. In following that, we felt like we had actually improved the security of Windows, and that was the reaction we got from the industry. So we decided, you know, that was an approach that worked. We built a bigger team. We built a capability for ongoing training. We built a capability for penetration testing. We built a capability of advising teams on product security. We built what we called security science, which was basically our in-house hacking group, to find new classes of vulnerabilities and then ideally find ways to eliminate them before they were discovered outside. We replicated the Windows push for Office, SQL, Exchange, some other products. And there were also some bad news. The slammer worm that affected SQL Server, the blaster worm that affected the XP client, that blaster led us to launch XP Service Pack 2. And Service Pack 2 primarily focused on what we called mitigations, basically things that wouldn't eliminate vulnerabilities, that make it hard or impossible to exploit them if they remain. And so by 2004, we had a good bit of experience, and we also knew that we hadn't gotten to a perfect solution yet. So a number of us came together to start to talk about, what would it take to create a mandatory process that the company would just have to do. We wound up briefing Steve Ballmer, who was the CEO, and his staff in the spring of 2004. Steve said, okay, this is going to be harder than you think it is, Steve, but it's approved. We're not ever going to talk about it again. Go forth and do it. We created SDL. We called it V2. We said that the security pushes were V1. And it was composed of training, technical content, the sorts of things we did during the security push, a final security review, which I'll talk about in a moment. And it was mandatory and effective July 1st, 2004. This is sort of a snapshot picture from a little later. It's sort of waterfall looking. Back in the day, Microsoft was mostly doing software development on a waterfall or spiral basis. And so we had phases, and there were activities in each phase, including things like threat modeling, static analysis, dynamic testing. That was something that was added not in the initial SDL. But basically, we had activities that were part of the process, and you had to do, and they created evidence, and at the end we had what we called the final security review to say, have you done it? And the final security review was two things. Number one, have you done all the stuff the SDL tells you to do and actually done it to the code? And number two, you can't ship known vulnerabilities. There's something that's been discovered, you've got to fix it. But it wasn't, we did some amount of penetration test that was much more prescriptive, in the sense that there are these things that SDL includes, and you have to have done them. And if you've done them, then you can't. Then you've met the requirements. The slide there says mandatory. Early on, a vice president called my boss and said, "Hey, I discovered there's this thing called the SDL. I haven't done it. I have a product that's ready to ship. What can you do for me?" And my boss said, "I can tell you not to ship." And he, the individual involved had to retask his product team to go back and do the various SDL activities. In another case, I remember a product group had built a product and claimed to have done the SDL, and their results were really just awful. We ran some of the tools that were supposed to be part of the SDL, found that they hadn't fixed a batch of stuff, and said, "Now go back and do this again." So that changed the software, and it also changed the culture. It got people the word that this is an expectation. Early reactions, and something important about the SDL. Threat modeling, which was this process that came from the late 90s and was the only design analysis technique that we had, and still the only design analysis technique that's sort of broadly usable, was too hard and not prescriptive enough. And it was really hard and not prescriptive at the beginning. Some of the tools were unusable. Some of the tools were unproductive. The process doesn't work for online services where we're releasing once a day instead of once every 3 years. Those were the sorts of things that that we heard early on. Because of those things, because of the new discoveries of vulnerabilities, because of new tools that enabled us to do secure development better, we pretty quickly, matter of fact, part of the initial SDL was the expectation that we'd go back and modify it. And we started out modifying every 6 months, went to 12 months, and then, later, sometimes 6, sometimes 12. But in every case, what we're doing was taking product group feedback, things that we discovered from MSRC cases that told us where, what new vulnerabilities we had to worry about, and issues of tools and usability that, like the ones I had on the previous slide. We had our security science team that was still working. They found new bugs, they created new mitigations. In a couple of cases, we were able to find a new class of vulnerability, build a tool to detect all instances of that, and eliminate it from the product before anybody on the outside ever reported it. Those were things that we considered to be real successes. We also worried about scaling. I remember talking to Ballmer at that meeting in 2004. We talked about training. He said, "Oh no, you have no idea how many developers this company has." Answer at the time was probably about 40,000. So we went to online training. We built a lot more tools. We also built a tool for automated requirements applicability and execution tracking. Basically, what do you have to do for this kind of software to meet the SDL, and have you actually done it? So that when we started out, we were using a whiteboard and Post-it notes, but we fairly quickly got to automation to help us know that we'd done what we were supposed to do. And back to the product teams, we eventually introduced a new process and a new threat modeling tool. You can actually download that for free from the Microsoft website if you're not familiar with it, or an evolution of it. Unusable tools, in some cases, we fixed them where we could. Occasionally, if we had a tool that wasn't very good, but it found a vulnerability that we knew was really bad, and we knew that the external vulnerability researchers were on the trail of, we said, suck it up and use that tool, because having the vulnerabilities reported and having to fix them is worse. That disease is worse than the cure we can offer you. We did deprecate unproductive tools. We did review the process, and an engineer named Brian Sullivan figured out a way to sort of refactor the SDL so that it made sense to still do the requirements, but do them in a way that was consistent with Agile Development, where you were releasing every day or twice a day or whatever. And that has served folks well over the years. I'm sorry, I'm getting behind the curve there. So experience, lessons learned. It was more successful than we had feared it might be. I mean, I still remember some of the early discussions. Will people stay committed? Will the engineers do the right thing? In the event, there was surprisingly little pushback, and people continue to do the SDL long after. I ran it for 9 years at Microsoft. I've been gone from line management of the SDL for 7 years and retired 5 years ago, and the process still lives. So that it's something that's gotten to be part of the way development is done. The developers really want to do the right thing. I talked about that. They're proud of the company. They want to be proud of the company. They want to be proud of the product and their work. They don't like seeing bad newspaper headlines, and they know that security matters. So if you give them the tools, the developers will do the right thing. And that brings us to the third point, which is really about, back to the title of the presentation. SDL is a product group activity that's advised by the security team. It's building security in as the product developers develop the product. Testing when done isn't something you do, and a testing when done based secure development process won't work. When the product is done, the security has to be done, and the product teams have to buy in to do that. We also found that continuous improvement was important. I talked about releasing the SDL in June of 2004, and then doing new updates. We always knew that we'd have to update it because the first version was developed pretty rushed, but it became pretty apparent to us quickly that, because security isn't static, because neither the defenses nor the offense are static, you have to bake in continuous improvement. And the continuous improvement has to be driven especially by newly discovered vulnerabilities. People find new classes of vulnerabilities, and that's nature's way of telling you to update the process and remove those vulnerabilities before the next iteration ships. Training is good. The developers have to know what they're doing, but if you can give them a tool that is right, that's better. Making them do something just for security is not good. We had from time to time iterations of tooling where you'd go to a separate database to record your security activities. But the profitable way to do tracking of something like the SDL is to just integrate it into the product bug tracking system. There's no reason you can't do that, and it's high payoff. Overall, it has worked. Customers feel like Microsoft did in fact do what they said they were going to do starting in early 2002. The industry has adopted and emulated the SDL. That's something I was especially proud of, as companies like Cisco and Adobe adopted SDL-like processes and made public statements that they'd done so. I was talking to a well-known vulnerability researcher a few years ago, and he said, I know you guys have done a good job because I tracked the market price of a Windows 0 day, and it's just gone up since since you created the SDL and started to do that. That's an interesting metric. How do you measure security when you measure it with the economics of a 0-day vulnerability rather than trying to do something more technical? Not what you'd think, but makes sense. So change. The big changes I think that we've seen in the last 15 years are probably diversity and speed. One more thing on the next slide. But when we created the SDL for Microsoft, we aimed at C, C++, and C#. And the SDL book that Michael and I wrote talks about exactly the SDL with the requirements that we had at the time we wrote the book. And the SDL process is that developers see has to be very specific. I'm looking at some text from Microsoft SDL 5.2 that's available on the web, and it says use the /analyze option for Visual Studio 2008 code analysis and fix message bugs that trigger messages 4532, 6029, 6277, probably a list of 25 bugs that are all must fix. So that's very specific, and it's great for C and C++. But if you're using 10 or 15 languages today, you've got to have that sort of specificity, tools and requirements for each one. That's a challenge that I wasn't expecting when we created the SDL. Makes it a little harder for adopters today, although the thing that makes it easier, that there's more attention to security tools. And so I guess that's a sort of a balancing effect. Speed, I talked about Agile and DevOps. I think that's something you can do. You can't let the developers tell you, oh, we have to ship, we don't have time for security. You have to train them. You have to integrate the security tools into the tool chain, train them to fix the security bugs, just like any others, and stay on track with the development process, or else you get behind, and it's not. And then you're back to where we were in 2001. And the third thing that I said has got changed to make things more difficult is what the U.S. government calls supply chain, what SAFECode in one of the documents we wrote refers to as third-party code. Basically, you're not writing everything you're using. We did have cross-team code reuse. We did have some components such as drivers, but mostly we wrote everything we developed. Today, with open source, with other commercial components, it's pretty unlikely that you write everything you ship. And so the question is, what do you do about it? And some thoughts there. Have a standard, have an inventory, know who's responsible. You really want third-party code to meet the same secure development standards yours does. If the third-party developers aren't doing that, then you either need to do some of it yourself or maybe get some other third-party developers. But the people who are going to attack your software don't care whether you wrote it or whether you imported it and somebody else wrote it. So by way of summary, this last slide, the SDL has been around for 16 years now. It works because the developers write secure software and the security team enables them to do that. So when you're building an SDL, when you're building a secure development process, product team buy-in is really the critical factor. And you need to motivate that, you need to train it, you need to provide tools and facilitation, but you can't inspect or test security in if the developers aren't building it in. So that's sort of my lesson learned and my summary for you after dealing with this process for more years than I should admit. I think that's the last slide. Let me pause now and happy to turn it over to Martin and take questions.
Thanks a lot, Steve. Round of applause there to you. It has to be virtual, I'm afraid, but I'm sure the audience is thrilled. That was a great presentation, and really, really sorry that we can't do this in live with the audience sitting there. But we do have questions. First one from Tolga. Tolga says, Intel introduced recently a hardware-enforced control flow integrity approach. Do you think that this has the potential to make control flow attacks impractical, such that secure software development practices will have to focus more on data-oriented attacks?
So the control flow integrity is something that we were worrying about at Microsoft, well before I retired, and we thought two comments. One, that's in the category of what I think of as a mitigation. It certainly makes it harder to do attacks. The potential vulnerabilities are still there, and so I think the summary in the question is probably a good summary of the answer. Control flow integrity is absolutely a good thing to have, and and as I've watched, there have been more and more generations with more and more power, more and more control to make exploitation harder and harder. But it's still a mitigation, and so the vulnerability researchers will find maybe data-oriented attacks, maybe what we used to call design level flaws in the logic of the software, rather than flaws in the memory management or control flow. And so you're not going to get to perfect, but I certainly am a supporter of control flow security mechanisms that have been introduced.
Thanks. We have another question from Arnaud. And Arnaud says, when is it too late for agile development to solve legacy problems? And when is it better to have a new, fresh start?
Well, I guess, if you've got a mass of legacy code, and it has been developed without consideration of security and secure development techniques, then you're gonna have to do something. Pragmatically, if people aren't attacking your software and you're reasonably confident of that, maybe you can skate by. If security becomes important, then there's really no alternative but to do something like the security push, or do something like make major changes and replace major components. That's a pragmatic judgment that you make, but the vulnerability researchers, or maybe your own internal penetration testing, will tell you how bad your situation is and how much you have to do. What's the criticality? What's the attacker profile? Does anybody care? Can people get at the system? Those are all considerations in the real world. But assuming it's a target, and assuming it's been developed without consideration of security, you're probably going to have to do something like a security push or replace batches of components.
Thanks. So to the audience, we still have some time for questions, so feel free to keep asking. Now I'm going to take a question from my colleague Daniela, and you mentioned threat modeling. And how would you do threat modeling when you're doing Agile? Because people never have time to do anything in Agile.
Well, that's a great question. In fact, and the answers there are maybe a little bit of a hedge. What we would say is to do a threat model when you're starting, when you're making major changes. Agile or DevOps, if you're changing a component or a piece of the system, and doing that on a half day or a 1 day of development basis, then you're not making much of a change. So you're probably not making a big change in the threat model. If you're introducing some new major functionality, then you just have to say, okay, I'm going to include thinking about the threat model in thinking about what I'm doing. My experience is probably more with larger software projects than it is with agile projects. But it seems like if you're trying to do some major new functionality or major new product or service without thinking about it first, without some level of design, without some level of architecture, you're probably going to have problems that aren't just the security. And so I think an opportunity comes naturally if you're sort of trained and encouraged to think about that. Sort of a hedged answer, but it's probably the best I can do.
You mentioned the Microsoft Threat Modeling tool, which is a great resource, as you said, freely available. I heard some rumors, or maybe it's actually on the website, that Microsoft will not be releasing further versions of that. Do you have any insights on why that's the case?
I do not. I had not heard that. I look at that site only occasionally. I have a copy of the tool on my laptop, but I don't know whether they feel that the approach has gone as far as it can go, or whether they have some new concept that they're moving forward with. I've been away for a long time. 5 years. I still talk to folks there, but I certainly am not up to speed on everything they're doing.
Yeah, we find that in our interaction with the developers, we find that there are quite a few people who use the tool, but primarily it seems they use it to draw the data flow diagrams, and they don't actually use the automatic threat analysis, threat modeling features. So maybe it's perceived as too complicated.
Well, I mean, I remember, so the big breakthrough on threat modeling that I talked about in the presentation was when actually a guy named Sean Hernan came up with the idea of stride per element. Basically, rather than draw a data flow diagram and then quote think of threats. He gave us a structured approach that says if you're dealing with a flow, then there are certain stride considerations, only certain stride considerations that apply to that kind of data flow that apply to a data flow. And so that sort of simplifies and focuses your threat modeling approach. The downside of that is that there are a lot of stride pieces per element for each element, and so the threat model sort of gets bulky. I mean, the example in Michael's and my book, goes through that, and you can see the complexity sort of getting big or just getting voluminous. So I think people may just feel like, okay, I understand enough to where I can draw a diagram and figure out what to home in on. The other thing is that it for some cases, for example, if it's a network flow, and the solution to spoofing and tampering is to use SSL. Why, there are lighter ways to decide to use SSL than doing the threat model. So so those are some real world considerations. And one last thing, I'm sorry to ramble on. Even at Microsoft, we didn't mandate the threat modeling tool. We said do a threat model, and product groups with more security experience and expertise might do that, using a whiteboard or a Word document, or using the tool just to draw the DFT. So it is a variable approach. I wish there were a more structured and automated one, but that, for design, that's just hard.
Great, thanks. I could do this all evening, but unfortunately, our time is limited. I have a final question from Daniela. How did you at Microsoft create awareness of actual risks related to security vulnerabilities, and how did the developers react to this approach? As you said in your slides, if there's a vulnerability, just fix it. Period.
So, the initial training, the Gates memo and the Gates email and the initial training were part of that motivation. Something I didn't talk about, but probably should have. On an ongoing basis, every year or maybe every 9 months, oddly, we would have what we called Blue Hat, which was an internal security conference. The name was sort of a play on the Black Hat conferences in Las Vegas. And we would bring in vulnerability hunters. And we would, and to an audience of Microsoft engineering development personnel, and they would talk about the things they were able to find and the things they were able to do to exploit security holes, new classes of vulnerabilities, new ways of attacking, new ways of thinking about software security. And those Blue Hat sessions were well attended, probably upwards up toward 1,000 attendees or more. And so they would get the word out to the general engineering population. These are the threats. These are the things that are really happening. This is why it's still important. These are the things that we need to be doing to address the real world issues.
Great. Okay, thanks a lot, Steve. I think our time is just about up. Thanks to the audience and your questions. And with that, we can call this keynote a resounding success, I believe. Thank you all.
Thank you very much, Martin. Thanks, folks, for inviting me. I hope you have a great day and a great rest of the conference.
And I really hope that we'll be able to meet in the flesh, as it were, at some later stage.
I hope so. Thank you. Bye-bye.